Hi everyone, welcome to the 8th lesson for topic 3.1 Bivariate data analysis. So we are still under the objective of fitting a linear model to the numerical data. So as you can see, there's only one learning outcome for the lesson today, which is how to use a residual plot to assess whether it's appropriate or not for us to fit a linear model to the data. So if you can recall from the previous lesson, right, I actually mentioned that for any sort of data, you can fit the linear model. So as long as you have a set of data, then you can fit in any model as you like. So that's why linear model is like one of it. So you can actually fit linear model to any set of data. But linear model wouldn't be the best for a certain type of data. Okay, so that's why when we first talk about scatter plot, right, we talk about there's like three areas that normally we use to interpret a scatter plot. So we start with the form. Okay, then after that we have the direction and also the strength, right? So when we talk about the second and the third area, right, we can actually quantify this. So which means that the direction and the strength, you actually look at the scatter plot, then you try to observe, then you give out what is your comment, am I right? You try to describe it from your own observation. So there's a measure which is called as the correlation coefficient that actually help you to quantify this. So which means by looking at the value that you got for your R, then you will be able to prove that whether your observation is correct or not. So whether the direction is positive or negative, then it will be depends on the sign of this R. Whether the strength is a strong one or a weak one, then it will be depending on the value, the magnitude of it, whether it's like nearer to 1 or it's nearer to 0. So for today's lesson, when we talk about residual plot, right, it will be focusing on the part for the form. So if you can remember, for the form, right, we discussed about three forms. The first one is if let's say the data set can be represented well in a straight line, then which means this is called as a linear form. Then the second one is that if let's say the data actually display a curve pattern, okay, so which means stuff like this, then you can see that this is like an exponential graph. So exponential model, which is like a non-linear model, will be more suitable. Okay. Then of course you can draw a straight line as well, but it's just not the best fit. Okay. Then after that, the last one that we have is that the one that you can't put in a straight line and you can't observe any specific pattern as well, which is like it's just scattered randomly. Okay. So you can't actually find any relationship when you try to look at the association between the x and the y, because whether the x increases or decreases, you can see that's like different that's going to give you a various range for your y as well. So you can't actually use your x to predict your y. So this is the part that is like the most obvious one, which means that just by looking at the scatter plot, then you'll be able to see that whether there's a relationship or not. So for today's lesson, for the residual plot, it's actually a helpful tool for us to differentiate about these two forms. Because as you can see, right, if let's say I try to move like some of the dots here a little bit lower, okay, maybe for example, I try to use the other color. If let's say I have this set of data, I try to add on this. Okay, so my question is, do you think that this set of data consider a linear one or a non-linear one? It will be very difficult for you to decide, am I right? So maybe it looks like a non-linear, then at some part it looks like a linear form. So that's why residual plot actually help us to look at the situation in a more clearer way. So that's why from the residual plot, we'll be able to see whether it's appropriate or not for us to fit a linear model to the data. Okay, so let's start with the lesson. Okay, so before we move into the introduction, let's do a quick recap on all the content that we have covered so far. So for the first objective that we did in this lesson is called as identifying the association, which we discussed in our first lesson. So in the first lesson, we have first introduced the how to construct a scatter plot. So from the scatter plot, you also learn how to observe and how you interpret it in the forms of, in the terms of the form, the direction, and also the strength. And then for these three characteristics, it can always be supported by the measure of correlation coefficient, which is the R. Okay, correlation coefficient. So that's what we learned in our first lesson. Okay, then after that, starting from the second lesson for numerical data, we are under the objective of fitting a linear model already. So which means we are trying to use a linear model to fit in our data. So I hope that from Tuesday lesson, you can remember that why do we need to fit a linear model? It's actually to help us to do prediction. Okay. So when we try to fit the linear model, then the first thing that we learn is how do we write the regression equation, right? So no matter is known as the least square regression line, the regression line, or the line of best fit, they are basically the same thing. So you learn how to write the regression equation, no matter is y equals to mx plus c or y equals to a plus bx. Okay, so for the equation part, you also learn how do you interpret the gradient, what is that meant by the gradient, and what is that meant by the intercept. Okay, so this is for the second lesson. Then after that, when we have the regression equation already, then this is the time that we try to do prediction. Am I right? So we always predict our RV from the EV only. Okay, so which mean in our concept, right, EV always come first, and EV is the one that we use to explain the difference in RV. So that's why we are going to use the value of EV to predict RV. We are not going to, so we will never do the other way around. So under the prediction, we know that we need to substitute a value of your EV to get your RV. So for the prediction, we discussed about how reliable is our prediction as well. So which means it will be depending on your R and also whether it's an interpolation or an extrapolation. Okay. Then after we did the prediction, we also talk about another measure which is known as the coefficient of determination, right? So this is the coefficient of determination. So of determination tell us that what is the variation that can be explained, how much variation in RV can be explained by the variation in EV. Okay, so coefficient of determination, which is R square. So this is about the part where we discuss if let's say the relationship is stronger, then which mean more variation than the model can actually explain. Okay, so that's the idea on what we have done so far. So let's start with the introduction for residual. All right, let's look at what is that meant by residual. So residual is actually the difference, okay, difference between the actual value and the predicted value by the least square line. Okay, so it seems very vague, but don't worry, we are going to explain it by looking at this scatter plot later. So that's why if we are trying to put it in a formula, then the residual will be equal to the actual y value minus of the predicted y value. Okay, so I hope that you remember that when we learn regression model, right? So the equation that I first write in the handout is something that looks like this: y cap equal to mx plus c. Okay, so why do I use the cap thing? It's actually to differentiate the actual y and the predicted y. So that's why everything that you get out of this equation is actually a predicted one. So that's why that is known as y cap. So when we try to write it in the short form, then which means the residual will be equal to y minus y cap. Okay, so let's try to understand it by using this simple illustration here. So as you can see, right, this is actually a scatter plot. So which means if let's say I try to remove this regression line in the middle, right, then this is the scatter plot that based on all the actual value, right? So normally when you are given a table, then you have the x value and the y value, and you are going to plot it according to their respective coordinates. Then that's how you construct a scatter plot. Then after you come up with the regression equation, then by using two lines, then you try to by using 2 points, then you are going to connect the 2 points together, and this is how you draw a regression line, right? So what is on this regression line is actually your prediction. So why do we need the prediction? Is actually you can imagine that if let's say I try to remove this line, right? So I'll be able to get something that looks like this. Okay, so as you can see, this data is good to represented by a linear model, right? But the idea is that if I do not have the regression model, how am I going to predict something? So for an example, if let's say for this part, right, my graph is going to give me a data range from 1 to 10. So imagine if let's say I were to predict what is the y if let's say my x is 5. So which means I want to find what is the value here. Okay. So my question is, am I going to predict that the data is here, or am I going to get this, or am I going to get this? So how do I know that which one is the most accurate one? So you can have various y that you can actually plot when you have the same x, which is 5. So this is why do we need a regression line. So the regression line is the best fit of the regression model here. So which is the line that best represented all the data that we have here. So when we have the regression line, right, then it's easier for us to predict something. So for example, if let's say I already know that the regression line is at the middle here, okay? So whenever I want to predict something, if let's say I want to predict what is the value when it's 3, then what I'm going to do is I'm going to substitute the value of x and to get y, right, to the equation. So this value is exactly the same thing when we try to plot it in our graph. So this is how I get my predicted y. So that's the idea of it. So any point for y that you get on this regression line is basically the predicted y. But as you can see, right, your predicted y wouldn't be always the same with the actual value. Because from this graph, then you definitely can see that, for example, if let's say we try to move this, like all this point actually is from the x equals to 1. So you can see the actual value is actually at 1 and at 3. But the one that I predict is actually in the middle. You get what I mean, right? So this difference of value between the actual value and the predicted value is actually known as the residual. Okay, so let's try to focus in a part of the first point here. Okay, so you can see that when x equals to 1, the actual value of y is 3. The predicted y is actually 2. So if let's say we were to find the residual, then it will be the actual value, which is 3 minus of 2. Am I right? Then I'm getting 1. Okay, so that's why you can see if let's say the actual value is above the line of regression, the residual will be a positive value. Okay, positive, because you can imagine that the difference will be the positive value, which all your actual value is actually larger than your predicted value, right? So when you use a larger number to minus off a smaller number, then the difference will be a positive one. Okay, what if now the residual is, sorry, the actual value is actually below the line? So for example, when I try to look at this one, okay, so as you can see, this point actually located below the regression line. So what is this actual value? So both of this is actually for x equals to 1 as well. The actual value here is 1, then the predicted value is 2. So the difference is the actual value, which is 1, minus of the predicted value, which is 2. So 1 minus 2, then you are getting negative 1, right? So that's why if let's say the actual value is below the line, the residual will be a negative value. Okay, so which means this point, this point, this point, they all have a negative residual value. Okay, so now the third point, if let's say imagine if there's an actual value that lies on the line, what do you think is the residual? So for example, if my one of the actual value is here, then what is the residual for this value? What is the difference between the actual value and the predicted? Then it will be 0. Okay, so if let's say the actual value lies on the regression line, which means the actual value is 0, meaning that the actual value that you have and the predicted value that you have, they has no difference with each other. Okay, so something that you can see, right? The question is that when you try to compare to the residual that you get from here and the residual value that you get from here, what is the difference? So you can see that if let's say this point is nearer to the regression line, which means the difference is smaller. Am I right? So in another words, which means that if let's say you have a point that is like very far away from the regression line, which means the residual value will actually become larger. Okay, so the further the actual value is from the least square line, which means the larger the residual value. So it's the same thing. If the actual value is nearer to the regression line, then which means the smaller the residual value is. Okay, so we're only talking about the magnitude of it, so which means that I'm not talking about the larger or smaller in terms of the positive or negative. I'm talking about the value itself only. So which means like -1 and -5. So -5, we are looking at the 5 and the 1, but not -1 and -5. Okay, so that's the idea. Okay, so normally how do we get these two value? Because when we try to find the regression, when we try to find the residual, we need the predicted value and we need the actual value, right? How do we get these two value? So normally we can get the actual value either from the data table. Okay, so this is the main resource that we will be using. Then the other one is by using the scatter plot. Okay, so this is quite rare, but yeah, basically you can just get it like how we did it just now. So by looking at this coordinate, then I know that when the EV is 1, the RV is 1. So I know that the actual Y value is actually 1. So whereas how do we get the predicted Y value? So you can realize that your predicted Y value is basically the points on this regression equation, right? So it's the same thing like how you do prediction. So we try to get it by substitution to the equation of the least square line. Okay, so now we'll be looking at two different examples so for you to understand better for the idea of residual. Example 1, the regression line connecting the height and the age was found to have an equation of height equals to 100 plus 2.5 times age. Calculate the residual value for John, who is 12 years old and 142 cm tall. Okay, so from the previous notes, we know that if let's say we need to find the residual value, then there are two things that we need to find beforehand. The first one is what is the actual value and what is the prediction. Okay, so in this case, our RV is the height, right? So that's why the question already gives us that John is 12 years old, which is our EV, and he is 142 cm tall. So that's why this is the actual height of John. So we will need to find out what is the predicted height of John. Then we can find out the residual value between the actual value and the prediction. So that's why let's try to use the regression equation here. So the height is equal to 100 plus 2.5. The age is given 12 years old, right? So multiply 12. Okay, so for 12 multiply 2.5, then we'll be able to get 30. So 30 plus 100, that gives us 130 cm. Okay, so which means by using this regression line, someone who is having 12 years old should be having a height that's 130. But in the actual situation, John is 142 cm. So that's why the residual is equal to the actual value minus of the prediction, right? So that's why we have 142 minus of 130, which gives us the residual is 12. Okay, so which means in another words, the information that we have as an actual one is going to be our age. So the one that we get from the equation is our age cap. So that's why we are going to use the actual to minus off the age cap. So when we get positive 12, which means that the number in the actual value is actually larger than the value that we get from the prediction. So that's why you have a difference of a positive one. So now let's look at the example for part B. So what is the residual value for Jane, who is 10 years old and is 118 cm tall? Okay, so same thing, we can try to find out what is our prediction for someone that is 10 years old first. So we have 100 plus 2.5 multiply 10. Okay, so that gives us 25. So plus 100, which is 125 cm. So we know that for someone that's 10 years old, the predicted height would be 125 cm. So Jane is now 180 cm. So as you can see, the actual value is actually smaller than the prediction. So that's why you can actually you can expect that the residual that you are getting later should be a negative value. Okay, so actual height minus of the predicted height. So from here we can get -7. Okay, so that's pretty much about example 1. So now we'll be looking at example 2. Okay, example 2, create a table of residual values for the following set of data stating all the answer correct to one decimal place. Okay, so by looking at this question, then you will realize that you are given this raw data. So this raw data is basically what you collected from the actual life, right? So that's why this is like your EV and this is like the actual Y value. But what is a problem for this question is that if let's say we want to find the residual value, then we need the prediction for Y. So how are we going to get that? Because in example 1, we are given the regression equation, so we can find the predicted y. So for this question, we are not given that piece of information, so how are we going to do that? Okay, so for this data, how can we get the regression equation? So how do we normally find y equals to mx plus c for a set of data? It's actually by using our TI-Nspire calculator. Okay, so now we'll be using our calculator to key in all the value that is given in this table. Okay, so let's key in the value. I hope that by this time you should be very familiar with this process already. So at least at spreadsheet, so you can only denote it as X and Y, okay, for both your column. So now let's try to input all the value we have. 1, 1, 2, 4, 3, 6, 4, 2, and then 5, 7, 6, 4, and last but not least, we have 7 and 5. Okay, so make sure you check again. You have 7 pair of value and all the value that you try to input is actually a correct one. Okay, so now how to find our regression equation? So we need to go to menu, right? So make sure before you proceed to the statistic analysis, right? Make sure you already denote your variable here. So menu and then go to statistics, stat calculation, linear regression. Okay, then the X list is our EV, which is the X, then the Y is Y. So just tap. So remember for the first result column, try to put it and column that is like next to your table. So which means just now we use the column A and column B, right? So leave C empty. Then after that, let's try to show your result in the column of D. Okay, D or E and so on. So just okay. Then we try to get the value. Okay, so sorry, I think I pressed cancel, right? Sorry, I can't look at the. Okay, so make sure it's at D, then after that, okay. Alright, so you can get your equation here. So as you can see, we can write down our answer in 3 decimal places or more. So in this question, since it's at 0 point something, I think we can write down for SF as well. So for this question, then we can have our regression equation is equal to. So if let's say you wouldn't want yourself to confuse yourself at the end, so you try to put y cap for your linear regression equation. So 0.4643x and then plus 2.2857. Okay, so just try to get this value from your calculator, the M and the B. Okay, so now let's proceed with our notes. Okay, so now from we have actually got this value. So now let's try to find out what is our residual value for each set of data. So let's try to copy for the first 2 row of this table first. So this is the X and also the actual Y. Okay, so you can just write down the actual Y here. So what we have here is 1, 2, 3, 4, 5, 6, and 7, and then 1, 4, 6, 2, 7, 4, and 5. Okay, so now how are we going to find this predicted value? Is to substitute the value that we have, right? So predicted value y. Okay, so for this then what are we going to get? So we substitute 1 into this equation. So it's like 0.4643, substitute the x with 1, minus of 2.2857. So you can round your answer in 1 dp for the question asks you to do so. So that's why we can write our answer as 2.8. Okay, so I purposely leave these 2 column a little bit larger the space because of you can try to write down how do you get this value. So same thing for the second one, your x is 2. So for us to find the prediction, we need to substitute 2. So 0.4643 multiply 2 and then plus 2.2857. Okay, so from here then we can get 3.2. So we try to do the same thing, substitute 3, substitute 4, 5, 6, 7 for all this EV to get your prediction value for Y. So yeah, you can spend some time to pause the video and then to get all your answer first, then you come back to resume the video to check whether you are getting the correct value or not. So you should have 3.7, 4.1, 4.6, 5.1 and also 5.5. Okay, so the last row is for your residual. So remember, for us to get the residual, we use the actual Y to minus the predicted Y. So which means 1 minus 2.8, and that will give us negative 1.8. Okay, so the same thing, we have 4 minus 3.2, and that gives us 0.8. Then when we continue, then we can get 2.3, negative 2.1, 2.4, negative 1.1, and also negative 0.5. So make sure you are not just copy the value here, but really to understand how do you get all this value from your calculator. Okay, so now let's try to look at our TI Inspire again. So if you can realize, right, every time when you conduct the linear regression, you'll realize that there's actually given residual here. So as you can see, when you move on to this part, right, and you move your cursor towards this cell, and you'll realize that you can actually get all the value for residual. You see, right, the first one is negative 1.8. Looking at our answer just now, you see negative 1.8. Then the second value that you can see is what? 0.785. So when you try to round it up, then what do you get? You get 0.8. Then the next one is 2.3. So you see 0.8 and also 2.3. So they are basically the residual, but you'll realize that it's pretty hard for you to read like this, right? And it's like very confusing. So what do we want is we want the residual value to shown in a column that they are located next to the row for the pair of the data. So how are we going to do that? So this is why I always ask you to make it a habit to actually leave your C column empty. Okay, so you try to do your linear regression here, and this is the part that we want to insert our residual value. So how are we going to do that? Go to the cell that below the part that is labeled C here. So this is the part, so you can see equal to what. So that's basically the operation that you actually carry out by using this calculator at this certain column. Okay, so for here, so now we try to connect all the value to shown under this column. So how are we going to do that? So make sure that you are in this cell. Then after that, you press the var, so which means is the variable. So you just press variable. Then your screen will actually come out this. So you need to press to link to. Then after that, go to step 1 residual. Okay, so as you can see, RESID. So this is like the residual part. So you just press enter, then you'll be getting all your residual with your respective pair. So which means for the pair of the data 1, 1, the residual is negative 1.755. For the residual for 2, 4, then it's 0.8. So that's why when you try to compare to the answer that we get just now, it's going to be like the same. So you can see 1, 1, the residual is negative 1.8. Then negative, 0.8, 2.3, negative 2.1, and then 2.4, negative 1.1, and so on. Okay, so that's the idea on how do you use your calculator to get all the residual value. Okay, so now maybe you will have this question. So why do I need to know how to calculate residual since my calculator already give me that? Okay, so for this question, we go back to the example 1 that we have. So you see, right, when we try to look at example 1, you are not given the set of raw data. So which means in another words, right, the calculator cannot actually help you to find out the prediction. Because if let's say you want to carry out the linear regression, then how are you going to do that? You don't have the raw data, you only have the equation, and they give you the pair of the data that they want to find out the residual. So that's why in this case, you wouldn't be able to use your TI Inspire to help you to find the residual. And it's actually very important for you to understand what is that meant by residual. Then after that, when you move on to residual plot, then you understand that how is that going to justify whether linear model is appropriate or not for the set of data that you have? Okay, but if let's say you have a large value, large number of data, then if you have the raw data, then this is how we are going to do that. So you can use your TI Inspire to help you to solve this. Okay, so just a quick one. If let's say you realize that when you press link 2, right, then there's a lot of like step 1, step 2, step 3 that come up like different number. It's not step 1 that you are getting. So which means that sometimes you might save your work. So after that, the number actually accumulate. So what you can try to do is you go to this cell. So you can go to this cell and then you just press enter. So you'll be able to look at all the operation below here. So you just move your arrow, then just like go to the right hand side until the end. Then you'll be able to actually check out the number for this one. So which means the idea is that imagine if let's say I have the other question that I want to solve, then I try to do it in the same document here, which means under the same page. Then which means for the second statistic analysis that I carry out, the calculator will actually name it as step 2. So that's why when you try to connect it here, then it will be step 2 residual. Okay, so that's the idea. So make sure that you link to the correct variable here. Okay, so after you settle that, just press enter lah, then you'll be able to go back to the same thing. Okay, so that's the idea on how your calculator works. So now let's look at the part which we'll be learning how to construct a residual plot. Okay, so once we got all the residual values, so we can construct a graph which is known as the residual plot. Okay, so a residual plot is also one type of scatter plot. Okay, but the thing that we try to plot on the Cartesian coordinate is a different one with what we have on our horizontal axis, which is the x-axis, is our explanatory variable. So this is the same thing as our scatter plot. Okay, but then what are we going to plot on our vertical axis, which is the y-axis, is going to be different. So what we are going to plot on the vertical axis is our residual. Okay, so that's the idea. So which means if let's say you're doing this, then you can actually draw a sample picture here. So which means this is the part that you will be labeling the EV, then this is the part that you will be doing the residual. So now let's look at example 2. How are we going to construct that? Okay, example 2, construct a residual plot for the data in example 1. So take some time to pause the video and copy down the answer that you get in example 1. Okay, so for x equals to 1, the residual is negative 1.8. Then for 2 is 0.8. For 3 is 2.3. Okay, then negative 2.1, 2.4, negative 1.1, and also negative 0.5. Okay, so now we can proceed with the constructing the graph. Okay, so yeah, what do you need to do is when you have a look at this, then you know that this is the number that we are going to plot it on the x-axis. So this is the value that we are going to plot it on the y-axis. So as you can see, you have negative value and you have positive value. So that's why when you draw your graph, then it will be having like two quadrants. So having a negative x, then the positive x. Okay, so that's why you can try to draw an arrow in the middle, then the first column for your Cartesian plane here. Okay, so I try to draw it beforehand so that I don't need to switch between the program. Okay, so now let's try to label the axis here. So we have 1, 2, 3, 4, 5, 6. Okay, and then 7. Then after that we have this. So since the maximum value that we have is 2.4 and the lowest value that we have is negative like 2.1, so that's why one grid here will be represent 0.5. Okay, so 0.5, 1, 1.5, 2, and then 2.5. So for our negative part, then we have negative 0.5, negative 1, negative 1.5, negative 2, and also negative 2.5. Okay, So now we can try to plot put in all the data points. So for the first one, when x equals to 1, residual is negative 1.8. So which means that we will have a plot here. So when x equals to 1 is negative 1.8, so it's at the quadrant below it. So negative 1.8, then it will be like in the middle, then slightly lower, so which means it will be somewhere here. Okay, then after that, move on to the second point, then we have 2, then 0.8. So which means 2, 0.8 will be nearer to 1, so it's like middle, then slightly higher, so it's like somewhere here. Okay, then after that, when x is 3, then the residual is 2.3. So that's why 3, then 2.3 is somewhere here. Okay, so by using the same idea, you can try to plot for the other, so negative 2.1, and then 2.4 for 5. Okay, then after that, next one, 6 is negative 1.1, 7 is negative 0.5. Okay, so after we get all this, then this is basically how the residual plot look like. Okay, so now we might need to label. So on the y-axis, this is our residual. For our x-axis, this is basically our EV, which is the x in this case. Okay, so now as you can see in the notes here, we can also use TI and Spire to help us to construct a scatter plot. So how are we going to do that? So same thing. So this is why we need to know how to actually write down the value here. So what we are going to do is the exact same process like how you do a scatter plot. So just go to add a new page. Okay, so this is data and statistic, right? If you want to create a scatter plot. Okay, so after you get this, then now the variable here. So what is the variable that you try to put on your x-axis? It will be your normal EV, right? So in this case, then it will be your x. Okay, then after that, for your y variable is going to be the residual value, right? So again, please remember to check what is the step 1, step 2, or like the normal one. So remember to get it from the sheet just now. Okay, so for me it's step 1, so that's why I'm just going to press step 1 residual. So after I press it, then I'll be able to get the exact same thing like what I draw here. So you can see it like at the bottom. Okay, and then 2 points going up. Sorry, let me try to just adjust a bit. Yeah, okay. So at the bottom, then 2 points going down, then 1 point at the bottom here. Then after that, continue to up. So you can try to check with your plot here. So it's just the graph that we have is a little bit narrow because of the width that we try to put is like not so large as this graph. But then the pattern is basically the same. Okay, so you should get this. Okay, so same thing, you need to know how to use it, how to draw it as well. If let's say you need to like fill in or add in the missing point, so you will need to understand how do you draw it, but not purely rely on your calculator only. Okay, so after this part, then now let's try to look at the notes. So the question wants us to comment on whether the linear model is appropriate or not. Okay, so that's the part that we are going to discuss now. So which is the last part for this lesson, which how is a residual plot helping us to assess whether a linear model is appropriate or not. Okay, let's try to look at the next part of the notes, then we'll be coming back later. Okay, so this is the part where we'll be discussing how reliable is the regression model. So which means that we can always feed the data into a regression model, but is the regression model the best model that we can do? Okay, so how are we going to assess it? It will be depending on the shape of the residual. So residual plots are useful in assessing the fit of the statistical model. Okay, so it can be used as a further evidence to verify whether the relationship between the two variables that we investigate, whether it's a linear one or it's a non-linear one. So how does residual plot actually do that? So let's try to look at these two simple example here. Okay, so the first one, this is the first case. So imagine if let's say this is the set of my data, right? Then you can imagine that when I try to when I try to fit a linear regression line into the data, then this will be the line that I get. So if let's say I were to create a residual plot out of this data, then how is that going to look like? So you can see that this point is basically slightly lower than your regression line. Am I right? So that's why we can expect that the residual is like pretty small and it's at the negative side. So I'll actually expect that maybe it's somewhere here. Okay. Then after that, when you look at the second one, so you see it's at the positive side because it's above the line, and the difference is actually just a slightly one as well. So that's why maybe I will plot it here. So when I go to the third one, it's going to be the same. Maybe it's a bit further when we try to compare to the first one, but it's still at the negative part. When we go to the next one, you can see this is the one that at the bottom right. So that's why when we try to read the residual, it's going to be a larger difference compared to the first 3 point, and it's at a positive. So a residual that we get is like the magnitude is larger, it's further, then after that maybe it's somewhere here. Okay, so what can you realize so far is that actually the residual plot is just a transformation or like the rotation of the regression line that we have. You can try to imagine that this is basically going to be the exact same thing if let's say this regression line is our x-axis. You see, right? Because when we talk about residual, we talk about residual is the difference between the actual value and the predicted value. If let's say the difference is 0, which means that the point is actually on the line, am I right? So that's why residual is 0. When we try to plot in the residual plot, it will be on this y-axis as well. Then if let's say the point is further, then which mean that what does that mean? Which mean your residual is bigger. So what happened is that our residual will be at the positive side and is further from this x-axis as well. So this is like how the whole thing is actually just like shifted until this side, and you can get a line like this. So this is like how you can actually imagine your residual plot. Okay, so let's try to continue. The next one, it will be nearer to this. Then after that, negative again, slightly further. Then positive again, slightly nearer. Then after that, slightly lower. Okay, then after that, nearly on the line. Then one more point here. Okay, so you can imagine this is what we can get from the residual here. So now let's look at this model. Do you think it's considered a good linear model? I think yes, right? Because this model is actually can be represented well by using a straight line. So that's why, what can you realize for this residual plot? So this residual plot actually do not have a specific pattern. Am I right? So the residual plot here has a value that is scattered randomly above and below the x-axis. Scattered randomly. So that's why if let's say the residual plot having all the data points scattered randomly, it actually suggests that the scatter plot is in a linear form. So which means you imagine when I try to draw the regression line, I have all the line that is like distributed, spread out left and right of this line. So that's why this will be a best fit of the line that I have, right? So if let's say the scatter plot is in a linear form, so which means it will be suitable for us to use the linear regression model here. Okay, so this is our case 1, which means if residual plots shows the value scattered randomly above and below the x-axis, which means it suggests that linear regression model is suitable. Okay, so now let's try to do a comparison. This is the second case. What happens if let's say it's a non-linear model and we try to fit in a regression line? So you realize that, yeah, this regression line is actually still in the middle, am I right? Because what is that meant by regression line is a line that actually minimizing the difference of the points, the square of the difference of the point between the line. So that's why this is like the best fit that we can find it here. Then obviously this line will be in the middle as well. So now let's try to construct the residual plot and see what happened. So this point is positive and is actually quite further, so that's why it's somewhere here. Then the second point is exactly on the line, so which means it's here. The third point, the residual is a negative one and is slightly lower. Then when we have the next one, so it's like the further is somewhere here. After that, this is like roughly the same. Okay, then become lesser, slightly lesser. So how many already? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we are reaching the 5th point. So now we have 2 more points at the lower part. So which means it's somewhere here, then after that somewhere here. Okay, then after that you will realize after this, then this become a positive, right? So it's here. Then after that, you have a further one, which is here. So what can you realize here? Although it's not a perfect curve, but eventually you can observe that there is a specific pattern, which is a curve. Am I right? So that's why this tells us that if let's say the residual plots show a specific pattern or the shape in the residual value. So what do you realize for this model? So as you can see here, actually this is not a very good linear model, right? If let's say I try to fit into this straight line, it wouldn't be like that suitable as well because they are not like spread out evenly like our case one. So that's why this will be much more suitable if we try to fit in a exponential graph. It's maybe it can give us a perfect relationship for that, but we doesn't need to know for that part. So we only need to know that if let's say when you try to transfer the residual value to a residual plot, then you can observe that there will be a clear pattern. So that's why this suggests that the scatter plot is actually non-linear. Okay, so that's why if let's say the form is a non-linear, which means the linear regression model may not be suitable for the data. So which means that if let's say you can imagine, right, if I were to extend this line and I want to predict something that's here, it's not going to be correct because what happened here is that if I were to substitute something that's like non-linear, which is like this, oops, let me try to redraw it. Okay, which is going to be like this, that passes through all the points like perfectly. This is like a exponential graph. Then what do you realize here is that this value should be like going up like this, am I right? So if let's say I were to predict for the value of 10, you can see that my prediction is here, but actually the prediction should be somewhere here. So that's why fitting a right model is very important to decide that whether your prediction is correct or not. So that's why we need this we need this residual plot to tell us that whether the linear model is a suitable one or not. Okay, so the last part of the notes here, so I can try to erase that. Okay, so the last part of the notes here is that interpreting the pattern in the residual plot or identifying the form is another skill. So which means in our syllabus, right, you are not required to do that. So the only thing that you need to differentiate is that either it's linear or non-linear. Because for non-linear, we still have a lot of model like either exponential, either like quadratic, or even things like if let's say you go up to like the third variable and so on, or the curve thing. So that's going to be like so much of the model that we can try to fit. But in our focus here, we are only going to fit the linear regression model. So there's only two for us. Either you can fit, is a good fit for linear regression, or is not a good fit, then it's commonly called as non-linear. Okay, so now we'll be looking at two examples, then we will end this lesson. Okay, example 3, comment on whether the linear model is appropriate for each set of data. Okay, so which means you see there's like there are 3 residual plots here and you are going to identify whether which one the linear model is appropriate. Okay, so you remember the characteristic just now. If linear model is appropriate, which means that the residual will actually randomly scattered above and also below the x-axis. So that's why, as you can see, right, let's try to look at the first one. So do you think there's a specific pattern? No, right? They are actually randomly scattered around. So that's why this will be a good linear model. After that, for the second one, then you can see that there's like this curve shape. So you can imagine if I were to imagine what is the scatter plot beforehand, right? Then actually the scatter plot will looks like this. So it's going to be like something like this. Okay, so that's why when you try to look at this, right, then when we try to fit, then this is what happened. Okay, so you can try to see that this curve is definitely not a good linear model. So the same thing for C. If we were to look at it from the view of the scatter plot, then how is that going to look like? Is that this thing is going to be further, so which means it's going to be maybe something like this. Okay, so do you think a linear model is appropriate? I don't think so. So you can try to imagine when I try to draw the line of best fit, it's like in the middle here. So you can see that's like one bunch of data points above, which is here. Then another bunch at the end. When the explanatory variable increases, then you have the other bunch that's having like negative residual. So that's why obviously when I try to remove this regression line, then you can see that this is not a good line that we want to fit in a straight line. Am I right? So that's the idea. So now let's try to write down the comment, like how should you actually answer it. So for part A, so we can answer A, then A in one part, then B and C together. So it doesn't need to repeat to write the same thing. Okay, so for graph A, yeah, so you can just try to practice to write down the exactly same thing that we learned just now. So for the residual values scattered randomly above and below the x-axis. Okay, and below the x-axis. So this is why a linear model will be suitable. Okay, so it suggests linear model is suitable. The linear model is appropriate, or let's say we try to follow the question, right? The linear model is appropriate. Okay, so now let's try to look at the part B and C so we can answer that together, so you do not really need to repeat because they are just the same. So for part B and part C, what do you realize? So the residual plot actually shows the same, shows a specific pattern, right? So that's why the residual plot, okay, show a pattern. Okay, so it suggests that the linear model is not appropriate. That the linear model may not be appropriate. Okay, so that's the idea of this. Okay, so now let's try to move on for the last example. So that's the part that we are going to combine everything together in like this question where we need to look at the R and also the least square line regression, then the residual and so on. Okay, so let's move on to example 4. Alright, so example 2 before we forget. So as you can see, we still left with one part which we need to comment on whether the linear model is appropriate for the data or not. Okay, so by using what we have just learned, so by looking at this graph, then you can see that all these points are scattered randomly as well, right? So that's why your comment will be a linear model. The linear model is appropriate. Okay, so the linear model is appropriate for the data, then you need to put in your explanation as well. Why do you say so? Because of you can see that all the data points in the residual plot actually scattered randomly. Okay, so the linear model is appropriate for the data as the okay. So the residual plot, yeah, so depends on you like how you want to phrase your word lah. So just make sure that they are, yeah, so you think like how I answer this one and how I answer the question just now is like different, but what they mean is actually the same, meaning that you need to actually explain that the values in your residual plot is actually scattered randomly. Okay, so has value scattered randomly above and below the x-axis. Okay, randomly above and below x-axis. Alright, so that's pretty much for this question. So let's go back to the last example. Okay, example 4, the marks for chemistry and physics tests were recorded in the table below for 10 students. Okay, so question A, the question wants to find out the correlation coefficient. So I hope that you should be pretty familiar with this. Write down the equation of the least square line of regression, the y equals mx plus c. So from C is going to be something that we learned in this lesson. Okay, so let's try to key in all the data first. So I'm trying to fast forward everything. So spend this time to actually look at your calculator and try to input all your value. Oh yeah, something that I just want to mention, yeah. So you can see that the question use C and P, but why am I using like chem and phi? So this is actually the same thing, like you actually have a risk there if you try to denote something that is like a single alphabet. So which mean using X and A isn't very good as well. So the idea is that you can see that actually for all the column in your calculator, right, is represented by a letter. So you can see this column is called as column A. This column is called as column B, column C, column D, and so on. So as you can see the alphabet here. Okay, so that's why when you try to key in something, if let's say you try to use a C here, right, later when you get your answer, you'll realize the calculator may ask you something that whether your reference want to follow the column reference or the variable reference. Because the idea is that if let's say you use C here, right, there's two C in your calculator. The first one is the column reference, which means are you going to use the C here? Or the other thing is, are you going to use the C, which is your variable? So that's why it can cause a lot of problem there. So that's why I'll always encourage you to actually use like two or three alphabet. So to indicate that there's difference from the column. So for the X and Y is still okay because of like X and Y is pretty far away and normally you doesn't have any data there. So that's why when we try to use X and Y, the calculator doesn't show error just now. But then if let's say you try to use C here, yeah, you can just try it out and you'll realize that your calculator will actually come out like syntax error. Because the problem here is you have a set of data in your column C and also you have a set of your data is at your variable C. Then you are the one that need to assign the calculator that which C is the one that you want. Okay, so that's the idea. Okay, so let me continue to input all the value. So after you got all your value, remember to double check again with your table to make sure that everything you put in is correct. Okay, so let's carry out the linear regression analysis. So in this case, we are trying to just follow the sequence because normally in your exam, there will be much more detail on how should you decide your EV and RV. So in this case, because of we doesn't have anything and from the residual that we need to calculate, right, it's written that the data pair is 80 and 78. So that's why it should be like 80, 78. So we can assume that chemistry is the EV, then physics is the RV. Okay. So and before you carry out the analysis, remember you are using like G and H. So that's why you might want to leave your I for your residual. So you should show your results at J. Okay. So let's try to carry out the analysis then. So menu, statistics, stat calculation. Okay, so the X is the chemistry, then Y is the physics, then just tap until the end here. So remember, if K also doesn't matter lah, so you have like one more empty, one more empty column that doesn't matter much. So if I were to change it, then I will change it to J. Okay, then okay. All right, then I'll be able to get my R here. So it's 0.9030. Okay, so remember always four decimal places for your R. Okay, so equals to 0.9030. Okay, so let's indicate that's R. Alright, so R equal to 0.9030. So I think this is a very obvious, it's a strong relationship and the direction is positive. Okay, so just write down strong, positive, linear relationship. Okay, so now we are going to look at the part to find the equation of the least square line. So it's just refer to your calculator as well. So based on the result here, then you can get your M and B, right? The gradient and the y-intercept. So remember, same thing. In this case, you can write 3dp or you can write 4. Okay, so maybe you can write 3 in this case. So 0.862 and then 14.332. So make it as a constant one. So which means in this case, our RV is actually physics, right? So that's why it's indicated by P. So P will be equal to 0.862C plus 14.332. Okay, so that's the part for B. So now let's move on to C. Showing your working, calculate the residual for the data pair of 80, 78, and 64 and 70. So check your answer with the help of your calculator. Okay, so which means we need to first find out our residual by using manual calculation first. So this is the pair of 80 and 78, right? So that's why we might need to find the braided value for P. So if let's say you doesn't want yourself to be confused, then remember that here you can always write down the cap. Okay, so P cap will be equal to 0.862. Substitute the C, which is 80. Okay, so this is the first value, so 80 and 78, right? So this is like the marks for chemistry, and we want to find out the fraction for physics. Then plus 14.332. So from here, then I'll be able to get my answer. So just use your calculator, and 80 plus 14.32, and that gives us an answer of 83.292. Okay, so to find the residual, it will be equal to the P, the actual P minus of the fraction, right? So that's why it's 78 minus 83.292. So you can write down your answer in three decimal place as well. So 78 minus your answer, then you'll be able to get negative 5.292. Okay, then after that, move on to the next pair, which is 64 and 70. So for 64 and 70, similarly, we need to find out the fraction for 64 first. So 0.862, substitute 64. Okay, so by using calculator, and we will be able to get the answer of 69.5. Okay, so similarly, residual equal to the actual P minus the braided P, which is equal to 70 minus 69.5. Okay, so the question, you can get 0.5 here. All right, so yeah, that's the idea on how you solve this. So now let's try to look at the part. So you can always try to check your answer in your calculator as well. So let's try to look at the pair. So remember to link it first, so it's easier for you to check the pair. So yeah, remember how to do that. So in a column of I, then just go to this place, then variable, then link to. So remember to check. In this case, right, my case here, it will be step 3. Okay, so for step 3, then menu, I'll just link it to my step 3 residual. Okay, especially you are doing everything in like the same sheet of a page. Okay, so you'll be able to get all this. So let's try to check our answer. So where's the pair? So the pair is 70 and 78, right? So we need to find out the pair, which is this one. So you can see negative 5.3. So that's aligned with our answer. Then the second pair that we have is 64 and 70. So 64, 70, the answer is 0.493. So you see there's a little bit difference in our answer. That's purely because of we are using manual calculation. So when we try to substitute, it's actually a rounded value already. So there will be a slight difference there. Okay, so if let's say the question didn't need you to show your working, but just write down your number for residual, right? You can always follow your calculator and then write down the exact value that you have. Okay, so yeah, that's pretty much the part. So D, explain the significance of the sign and the size of the residual in part D by using regression line. So yeah, which means that we need to look at these 2 points. So what is that indicates by negative and positive by using the regression line? So which means that if let's say the residual is negative, yeah, so the sign of residual, okay, indicate the location of the point, right? So which means you know that whether it's above the line or it's below the line. So indicate the location of the data point. Okay, so you can try to explain further. So which means having a negative, having positive residual means the data point is above the line. Okay, so I think I'm just going to read it out, then you try to write down yourself. So means that the 80 and 78 is above the regression line. Sorry, this one having a positive, so which means 64 and 70. Okay, it's positive, so this is a positive value, right? So 64 and 70 is above the regression line. Okay, then you're going to continue to write it for the other pair. So having a negative residual means that the point of 80 and 78 is below the residual. Okay, so this is about the sign. Then you can, for the value part, then which means that by looking at the magnitude, the size of the residual, the size, meaning that if let's say the point is further from your regression line, which means the residual is bigger, right? So that's why by looking at this, then you can write that the size of residual indicate how far the point is from the regression line. Okay, so that's why 8078 is further than 6470. Okay, so that's the idea on how you should answer. Okay, so part E, construct the residual plot in your calculator, decide whether the linear model is appropriate or not. So we are just going back to the question. Okay, so as you can see, we already put in, so remember this is set 3 residual. So just go to the page where you already, plot your graph. So in this point, then it will be your chemistry, right? Yeah, your explanatory variable. Then for this point, remember it's stat 3 residual. So stat 3 residual depends on what you have in your calculator. Okay, then as you try to see here, yeah, do you see any fixed pattern? There's no, right? That's randomly scattered as well. So that's why for the answer for part E, a linear model is appropriate because the value is scattered randomly above and below the x-axis in the residual plot. Okay, so that's basically the same thing like how you answered the previous question. So which means if let's say that's randomly scattered, then linear model is appropriate. If you get a fixed shape, then which means linear model is not appropriate. Okay, so I hope that explained. Alright, so that's basically pretty much of this lesson. So try to spend some time to do your homework and to understand the concept. So we are going to we are going to discuss further on the exercise in the next week physical class. And tomorrow we have consultation and hour as well. So see you if you have free time. Alright, thank you.